Hello, this is Mrs. Brown, and today we're going to do a brief overview of radical equations and solving them. So the power property of equality says if I have a equals b, then a squared equals b squared. So for example, the square root of x equals 5. I can square both sides. The square root of x times the square root of x is just x, and 5 squared is 25, so x equals 25. And I can use that to solve, okay? The steps to solving radical equations, the first thing is you're going to isolate the radical sign on one side of the equation. This one was already isolated, so I didn't have to do that. Once I've done that, I'm going to square both sides and then finish solving if there's anything like under the radical. So if this was like x minus 1 under the radical, then I have like a little bit extra at the end. Okay, so let's take a look at some examples. Okay. If you look at this one, there's a minus 2 outside of the radical sign on the same side of the equation. So the first thing I have to do is isolate the radical, which means I have to get rid of the minus 2 by just adding 2 to both sides. So the square root of n equals 9. And then I'm going to square both sides. So squaring it, square root of n times the square root of n is n, and 9 squared is 81. And so I'm all done. Okay. If I take a look at this one, the minus 1 and the 2 are underneath the radical sign. So my radical sign is already isolated. I cannot subtract 1 because it's part of the radical. It's underneath. So now all I can do is square both sides. Okay. So the square root of 2t minus 1 is 2t squared is 2t minus 1, which equals 25. I add 1 to both sides. So I get 2t equals 26. When I divide by 2, I end up with t equaling 13. Okay, so again, for this one, I had to add 2 first because it was outside the radical sign. I had to square first because everything was under the radical sign. Okay, when I look at this problem, part of the problem is under the radical sign and part of it's not. So I'm not going to do anything with a 4 because it's part of the radical, but I have to get rid of the minus 2 by adding 2 to both sides. So I end up getting the square root of c minus 4 equaling 12. Now I can square both sides since I have the radical isolated. So c minus 4 equals 144. And so when I add 4 to both sides, I end up with c equaling 148. Okay. Again, if it's under the radical sign, you have to square before you can deal with it. If it's outside, you want to get rid of it before you'd square. Okay. So let's take a look at one more example. Okay. The radical sign is already isolated, so I can square both sides. Okay. The square root of x plus 1 squared is just x plus 1. Equals, and then I have to FOIL that out. Remember, x minus 1 squared is x minus 1 times x minus 1. So it's x squared minus x plus 1. And so this becomes x squared minus 2x plus 1. So now, okay, I want to get all of the x's on one side. So I'm going to subtract 1 and I'm going to subtract x. I'm just going to do those both in one step. Okay, so this gets this side to equaling 0. So I get x squared minus 3x. Okay, the 1's cancel. So 1 minus 1 is 0. And now I can factor out x, the GCF. So that's going to be x times x minus 3. So then I'm looking at what makes those zeros, what makes it true. Well, when x is 0, or when you look here, that this would be when x equals 3. Except for here, I have to be careful. I have to check my answers, because if I don't check my answers, I may have like an extra one that doesn't really work because of the whole square root thing. So if I go back to 0 plus 1 equals 0 minus 1. Well, this is the square root of 1, which is all fine and dandy, but this would be negative 1. And you're not going to take the square root of 1 and get the -1. So this is an extra one. We don't use that one. If we check 3, okay, that gives me 3 minus 1. And so the square root of 4 is 2. It gives me my positive root, and I am good because that's what one will work. So I had an extra one when I did this. You have to be real careful and double check to make sure you have the correct answer. Okay. I hope this helps, and have a fabulous day.